Welcome to this Solidworks 22-minute webinar entitled Simplify the Science of Electrical Mechanical Design. My name is Cliff Medling. I'm going to be your host, and we're going to jump right in and get started as we have a lot to cover in just 22 minutes. We're going to go ahead and jump right into the first poll question here. And at your company, do the products your company produces contain any of the following? And this is select all of these that apply. Electronics or PCBs, cables, wiring, harness, fluidics, hydraulics, or none of the above? Are you strictly mechanical? Cables, wiring, and harness is 73%, 65% for PCBs, only 19% strictly mechanical. Interesting. This is very good. With those results, I wanted to go ahead and introduce our presenters today. Again, we have a couple subject matter experts here. First of all, Lou Feinstein is SolidWorks Portfolio Management for IoT, Mechatronics, and ECAD Strategy, but has previously worked in advanced technology at such companies as Textron, Bell Labs, EMC, and his goal is to really infuse the electrical DNA into the SolidWorks portfolio of products. Next, we also have Josh Moore on the PCB side. Josh is a product portfolio manager for the SolidWorks PCB products and technology. Josh has over 20 years of PCB design, software, product marketing, and product management experience. Prior to joining Dassault Systèmes SolidWorks, Josh worked at several PCB software vendors, including Cadence Design, Mentor Graphics, and PAD. So Josh and Lou, thanks for joining, and we'll get right into the presentation.
All right, thanks, Cliff. So this presentation and webinar is going to focus on mechatronics design solutions from us here at SolidWorks. Lou and I are going to talk a little bit about a couple of examples with customers who are using our products and technology to develop their mechatronics and electromechanical devices that they produce. And we're going to talk a little bit about what it means in terms of mechatronics, because when we say that word to our customers and the people that we talk to, it tends to mean a lot of different things to a lot of different people. So one of the things we did was we just took a straight up, what does Wiki define mechatronics as? And I know
we didn't expect you to read this slide. So.
Yeah.
The other slides won't be this long and boring.
Well, there will be a test at the end. It's one of the poll questions. So quite literally, Wiki defines mechatronics as the multidisciplinary field of science that includes a combination of mechanical engineering, which most of you are familiar with, electronics and telecommunications engineering, system engineering, and control engineering. And based on the poll question, it sounds like a lot of you are actually in these fields, one or more of these fields in the products that you develop. Originally, as most of you know, mechatronics started off as just a combination of the word mechanics and electronics, and that tends to be a lot of the customers that we deal with here at SolidWorks that are either designing simple electronics in a box, so they have the electronics part, they have the mechanical part, or they're designing control systems as part of their electromechanical products and have cables and wires and harnesses, or the combination of all of that in more sophisticated mechatronics applications where they've got a little bit of everything, including fluidics and hydraulics, cables and harnesses, PCBs and electronic control systems, all wrapped up in some kind of mechanical enclosure. So as we go through this presentation and this webinar, we are really going to focus on the two parts of the aspects that Lou and I deal with in terms of the electrical engineering design products and solutions, as well as the cable and harness and wiring capabilities of the electrical products in the design of these mechatronics products and solutions. So let's talk a little bit about the anatomy of a mechatronics device. Again, this is the kind of the conversations we have with customers. We'll take a simple, in this case, mechatronics device. So think of it as a electronics in a box or some kind of electronic device that has wires and harnesses. So you can see the two schematically driven applications, one on the left for wires and harnesses and one on the right for electronics design. These really drive and coordinate the mechatronics device for whatever it is that you're going to create. So if we look at something classic like this, a mechatronics device that has some kind of embedded electronics, has some kind of electrical interconnect hooking up the motors and printed circuit board, the control systems. You've got a mechanical assembly in which all of this fits into and has to fit, of course, properly to function. And then you've got some kind of kinematic analysis for figuring out, is the thing moving? Where did it go? What's it doing when it's moving? And getting that feedback to the control systems to continue the motion or to make corrections or whatever the case may be. In terms of a smart or connected or an IoT type of product, same anatomy generally applies. You've got power source, you've got embedded electronics, you've got wire and harness interconnect, you've got a mechanical assembly, but you've also got now some kind of web-enabled application, whether it be a simple connection to a smartphone or something that's communicated with or has some kind of intelligence through a cloud mechanism. But again, in terms of the design and solutions from Solidworks, it still applies to whether you're doing simple electronics in a box, you're doing a smart connected IoT product, or you're doing something more complex with control systems, wires and harnesses, or putting it all together in whatever kinds of products that you create.
Well, where do you start with this with mechatronics? So here at SolidWorks, let's take a little walk through history. So when you think about SolidWorks, you think about for how many years SolidWorks is solely a mechanical company, and you think about it in the case of a piece of industrial automation equipment. Really, SolidWorks has been the frame, the frame in the housings of the system. So you can think it as the skins and the bones of the system. So when you really look at it, it's a very mechanical centric universe that we've been in. But over the last 5 to 6 years, we've really seen a change in the technology, and this is where mechatronics really starts to begin. So the next piece that we looked at is when you think about one of these industrial automation pieces of equipment, is we really are talking about systems with cables and wires and harnesses and sensors and motors. And, basically we have PLCs, we have embedded electronics, we have all sorts of new technology. So when you really think about it in terms, it's really like a central nervous system, the motors, the muscles. So what we're seeing is you're seeing SolidWorks historically being the frame, the skins of the system. Now SolidWorks Electrical, SolidWorks PCB. Now the next piece of the mechatronics system is really bringing it all together, where you have the muscles and the motors and the systems coming together. And when you really take a look at it, it's really a combination of systems and combinations of parts. And basically now, once you have the interconnect of like I said, the processor, the brains of the unit, and basically the sensors, it could be optical sensors, any type of sensors. They're really like the eyes and the ears of the system. So what we've created is really a good analogy is the human physiology, is that we've really created a system of systems type approach. And that's what really mechatronics is about. It's about bringing the electrical and the mechanical. And the terms here, we're talking about electrical, meaning electrical interconnect, as well as electronics. So we talk about electrical and mechanical integration, and our tools all work together.
So before we jump into the rest of it, since we're talking about the integration of electro and mechanical, we'd like to know, what is the current level of communication, collaboration, and workflow between your mechanical design teams and your electrical design teams? We've kept the choices fairly simple and straightforward without getting into a lot of nuances in terms of some things work good, some things don't work good. But by and large, is it effective and efficient? Do you collaborate well together? Do you communicate well together? Could it be better? Yes, we have a process that basically works today, but of course it could be better. Or is it painful and inefficient? So make your choices. I'll give everybody just a second on that.
And only 9% have effective and efficient. So,
all right.
So we're in the right place, I guess. And everybody, there's always could be improvement, but maybe we can help out those painful and inefficient ones down there at the bottom. So
yes, absolutely. Okay, thank you, everybody. All right, so let's talk a little bit about the SolidWorks design ecosystem. So as Lou said, most of our customers are very familiar with SolidWorks as a mechanically oriented product solution workflow. And most people probably know that we also have simulation, we have PDM, we have solutions for plastic and manufacturing documentation. But as we look to round out our product design solution and really start getting into mechatronics products and technologies that we deliver to our customers who are creating those kinds of products, if you look at the ecosystem now, it really spans everything from initial concept and creation of both the mechanical side, the enclosures, the cases that the devices are going to fit into, but also on the electrical and electronic side for figuring out how to create the brains or the smarts of the devices that you guys are creating, as well as how do you get all of these pieces hooked up together so that everything talks to everything in some kind of control mechanism. So in the Solidworks ecosystem, we really have now an integrated workflow, and depending on where you're starting from and how you're creating your product, either leading with the mechanical aspect, leading with the wiring aspect, leading with the electronics aspect, one or all of those workflows can be used either independently or in conjunction with each other, and collaborate and communicate more effectively between the design teams, because now everybody's essentially on the same set of technologies, the same solutions, driving the products you create from end to end.
So one of the points that we really want to make is that our SolidWorks mechatronic solutions were all designed to be collaborative right out of the box. They have the DNA of SolidWorks, meaning we tried to make them easy to use as possible. And the other piece that's really, really important to know is our products, no matter if it's SolidWorks Electrical, SolidWorks PCB, or even the interfaces in the SolidWorks, were all purpose-built for mechatronics. These are not add-ons. They are not additions. They were designed from day one to be purpose-built. Now, I'm going to talk about a customer that me and Josh had the opportunity to visit about 2 weeks ago. A really fantastic company, company called Shadecraft. And let me give you a little story about Shadecraft. I'm going to play a video in the background. And it's really, it's a company that makes robotic systems. In this particular case, we're showing you their Shadecraft umbrella or parasol. And it's really an outdoor AI hub. And what do I mean by that? Well, let's take a little, I'm going to set the story a little bit. Imagine you're out on the deck reading a book on a sunny day with the kids, and you have Shadecraft. Let's talk about the story about that. So what you're seeing is that just think about how many times you're out there on the deck with the kids getting engrossed, or you're reading a book, or you kind of get distracted, and you have to always reposition your umbrella. Could you imagine having a parasol that's intelligent? It's a robot it's a cobot that's safe to be with you, that actually self-adjusts to the angle of the sun from your position so that you'll never get burned again. Just think about the technology there. Well, it goes a little bit beyond that, because this is an artificial intelligent hub. Well, think about it. Well, some of the other technology that's built in here that really makes it a mechatronics device is the ability to understand air quality. So think if you live in an area where you have really poor air quality, and these guys happen to be in California, so they kind of it's near and dear to their heart. No offense to anybody in California. But what it allows you to do is to get information in real time from the system and make informed decisions about going outside, doing extraneous activities where the pollution rates or the toxicity of the air could actually be negatively impacting you in that case. The other piece of the technology is here is that when you take this particular robot and you can connect it to your home automation or your alarm system, it has a 360-degree high-resolution camera. And what it allows you to do is that just think about if you're in this pool area or other areas where kids get into, just think about the possibilities when this intelligent technology can monitor areas and can report back to your centralized, home automation system. Just think about the tragedies that can be avoided through the automation technology. So what we're looking at here is an intelligent parasol that goes way beyond technologies. It's really embedding the true mechatronics and the IoT enablement in a very simple, easy to understand use. And this is really Shadecraft, and it's the world's first AI hub, and it's really designed in SolidWorks and using our mechatronic solutions. Very proud with them. The company's fantastic. If you get an opportunity to take a look at their website, the technology that they have, it goes way beyond any kind of parasol. So they're just a great company that they work on. So what we're going to talk about a little bit, and we're really going to focus our little attention here for me and Josh, is really to talk about a product that we've imagined, and we call it Beamy, and it's really a high-tech device that allows you to project and to watch videos and movies and do all sorts of stuff. It's an internal home entertainment center / security system, and really we're going to want to walk through how our tools are used to put this together. So we're going to walk through that right now, and I'm going to show you right now SolidWorks Electrical. And basically, what you're going to do is we're going to explode Beamy, and you're going to see a lot of technology in here. So in the case of Beamy here, you'll see that we can see inside. This is a traditional SolidWorks 3D model that's enabled with SolidWorks Electrical. Now here in SolidWorks Electrical, we're going to define the batteries, the speakers, the electronics, the projector, the assembly, and all the wires and cables that really go into it. And you see that we just created that single schematic. And any part we can actually define, and mechanical parts are added. As the parts and assemblies are added into the SolidWorks Electrical, we use real-time collaboration to instantaneously add the parts to the SolidWorks componentry for addition by the mechanical engineer or designer. But you can conversely go in the other direction, whereas the mechanical engineer can actually place the parts inside of the SolidWorks model and associate it to the electrical engineer, making it really, really easy to make sure that you have that mechatronics bill of material and that your mechatronics assembly with your electrical interconnect is all attached. And also, we can actually integrate SolidWorks PCB into that integration. And one of the things that once you have everything integrated, we really can design everything. And once it's all in the assembly and ready to go, we can auto route the wires and cables and really, really simplify the creation of interconnect within the product. And it doesn't matter what you're connecting and interconnecting, it's all schematically defined. So this is one aspect of mechatronics, and it's regardless of what kind of technology you're using. In this case, we happen to be using high technology.
Yeah, so in the case of the embedded electronics inside this thing, same kind of technology applies. Instead of defining the wires and interconnect between the various mechanical and non-mechanical devices, now we're going to have technology that looks at designing the schematic, designing the printed circuit board that goes into the brains of the Beamy device. So here in SolidWorks PCB, there's this traditional schematic and place and route applications, simulation applications for doing analysis of the signals. The benefit of the integration with SolidWorks PCB and SolidWorks Mechanical is the ability to seamlessly and intelligently push the electronics design to the mechanical environment for form and fit checks and doing clearance detection and making adjustments on the mechanical side for any mechanical clearance violations or interference that comes along, and then being able to pass that information or that change back to the printed circuit board designer seamlessly and intelligently. All right, so we're right up against the time here, right at 20 minutes. I'll have to look to Cliff to see if there's any questions online we'll be able to answer. But we just want to sum this up a little bit. Using the mechatronic solutions that Lou and I have talked about and the SolidWorks technologies, both from mechanical, from electrical, and PCB, this mechatronic solution and this workflow simplify and streamlines your workflow, your mechatronics design flow. One of the things that we find from our customers, as we saw in the first poll question, about how much goes into the products that you design, but in the second poll question, how inefficiently or how much better it could be being able to communicate more effectively between the design teams. This technology, these solutions are really aimed at bridging that gap between both the mechanical engineering teams and the electrical design teams so that they can better communicate together, so they can better collaborate together and streamline their design flow. In terms of communication, a lot of what we talk to customers about is really enabling different design teams to communicate more effectively. And a lot of it really comes down to, if nothing else, lingo. The mechanical guys and the electrical guys speak a different language. They have different data sets. They have different requirements and priorities. So using this workflow and these collaborative technologies and solutions for designing your mechatronic products, it really allows for a better methodology of communication to better align the priorities and requirements between the different design teams, and better and more efficiently get your products designed and out the door. So with that said, we'll open it up to a last couple of poll questions, and then we'll take a couple of questions from you guys. But I'll sum this up by, if you're interested in any of the technologies that we've shown or want to talk to somebody about improving the design flow, please contact your local SolidWorks VAR for more information or a demo.